Students, our next topic is grouping of identical cells. There are three types of grouping of identical cells. First is series grouping of cells, second is parallel grouping of cells, and third is mixed grouping of cells. First we will start with series grouping of cells. When n identical cells, each of EMF E and internal resistance R are connected to an external resistor of resistance capital R as shown in figure, then all these cells are said to be connected in series. In series grouping, negative terminal of first cell is connected to positive terminal of second cell, negative terminal of second cell is connected to positive terminal of third cell, and so on. Now equivalent EMF of n cells in series, this will be, we know that in series combination equivalent EMF is given by equivalent is equal to E1 plus E2 plus E3 plus En. As all the cells are of same EMF, therefore because all the cells are identical, therefore E1 is equal to E, E2 is equal to E, E3 is equal to E, and En is equal to E. This will be, therefore equivalent EMF will be E plus E up to n terms, therefore this will be Ne. Equivalent internal resistance of the n cells will be R1 plus R2 plus R3 up to Rn. As all the cells are identical, each have internal resistance R. This will be R plus R up to n term. This will be Nr. Now the total resistance of the circuit is R plus Nr plus R. Therefore current in the resistance R, will be, this will be total EMF upon total resistance. Total EMF is Ne and total resistance is Nr plus R. Now the special cases. If external resistance R is very small in comparison to total internal resistance of all the identical cells, then if R is very less than R, then R can be neglected in comparison to Nr. Therefore Nr plus R will be equal to Nr. Therefore I is equal to Ne upon Nr. N cancels N. This is equal to E upon R. Therefore current in the external resistor is same as the current due to single cell. Second case, if R is external resistance R is very greater than total internal resistance of all the identical cells, then Nr can be neglected in comparison to R. Therefore Nr plus R is equal to R. In this equation Nr plus R is equal to R, because Nr is small or R is very greater than Nr. Therefore I is equal to Ne upon R. Therefore current in the external resistor is n times the current due to single cell. Therefore in series grouping of identical cells, current drawn is maximum if external resistance is very high in comparison to total internal resistance of all the cells in series grouping. Therefore in series grouping, current drawn will be maximum when external resistance is very high in comparison to the total internal resistance of cells connected in series. Now the parallel grouping of cells. When m identical cells, each of EMF E and internal resistance R are connected to an external resistance of resistance R as shown in this figure, then they are said to be connected in parallel. In parallel grouping, positive electrodes of all the cells are connected at one point and negative electrodes are connected at another point. As all the cells are connected in parallel, therefore their equivalent internal resistance is given by, as equivalent internal resistance in parallel is given by 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon Rn. As R1, R2, Rn is equal to R because all the cells are identical. Therefore up to m terms, because there are m identical cells in parallel. Therefore this will be 1 upon Rp is equal to m into 1 upon R. M into 1 upon R can be written as m upon R. Therefore Rp become equal to, taking its reciprocal, Rp become equal to R upon m. Therefore total resistance of this circuit is external resistance plus total internal resistance. Total resistance of the circuit is R plus R upon m. In the parallel combination of identical cells, effective EMF is equal to EMF of single cell. Therefore, effective EMF is equal to E. Total resistance is R plus R upon M. Therefore, current in the external resistance is I is equal to E upon R plus R upon M. On solving this become ME upon MR plus small r. Now the special case. If external resistance R is very small in comparison to total internal resistance of all the cells in parallel, then R can be neglected in comparison to R upon M. Therefore, I is equal to E upon R upon M. M goes on upper side, this is M into E upon R. Therefore, total current in the external resistance is M times the current due to single cell. Second case, if R is very less than R, internal resistance of a single cell is very small in comparison to external resistance R. Then R can be neglected in comparison to MR. Therefore, I is equal to ME upon MR. This is equal to M cancels M is equal to E upon R. Therefore, when internal resistance of a cell is very small in comparison to external resistance R, then current in the external circuit is equal to current due to single cell. Therefore, in parallel combination of cells, current drawn is maximum when external resistance is very small in comparison to total internal resistance of cells in parallel combination.